We are third year EC students of SJC Mysore, presenting the video demonstration of our project titled Automatic Food and Temperature Control, which is being submitted as a part of Phase 1 for TIIC IADC 2014 under the guidance of N. Shiva Prasad.
Fish is one such creature that fancies food. It gobbles everything you feed it, even if it is already stuffed. But such overfeeding can result in lethal changes in the water chemistry. As a thumb rule, experts suggest that a fish should be fed not more than what it can completely consume in 3 minutes. Also, there are certain breed of fishes such as the catfish that needs to be fed at a particular time. Keeping these considerations in mind, we have designed a system that automatically feeds the fish by proper amounts at the required time. The hardware implementation of the system consists of an alarm clock whose output is fed as the input signal to the signal conditioning section. It consists of 2 transistors to enhance the signal from the clock, an LPF that acts as an integrator, and LM324 quadruple operational amplifier from Texas Instruments for amplification. The non-zero reference voltage ensures that the circuit is immune to any small voltage that could be present at the output of the alarm clock at a time other than the time the alarm is set. At the specified time, the output of this stage is 4.16 volts for nearly 10 minutes. The next section restricts this output pulse to a duration of 5 seconds, which acts as a short interrupt to the MCU. It consists of an LM324 amplifier operated as a comparator that goes to logic 0 after 5 seconds. And this output, along with the previous stage output, is compiled by the SN7408 quadruple AND gate to provide the proper interrupt to the MCU. On reception of the interrupt, the MCU drives the DC motor. The shaft attached to it makes the disc to rotate, and while it does, the small hole on the disc makes the food to fall into the aquarium. Let's look at the demo. The food is fed when the alarm hand is coincided with the hour hand. You can observe that the position of the hole before and after the rotation will be the same. We have set the delay in the program such that even after 50 rotations, the hole position lies within 1 cm. This is done to ensure that the hole doesn't keep shifting its position considerably and after some days end up just below the food, letting the entire food flow at once. The optimum temperature of a fish tank depends on the particular fish. For instance, tropical fishes survive between 24 to 32 degrees Celsius. There are readily available heaters in the market to ensure that the temperature doesn't fall short of the lower bound. At higher temperature, oxygen content in the water decreases, but the metabolism of fishes increase, making it extremely difficult for the fishes to breathe. Hence, it calls for a real-time vigilant monitoring. To sense the temperature, we are using LM35 temperature sensor from Texas Instruments. As the sensor cannot be directly inserted in water, we have inserted it into a tube and the terminals are properly insulated using silicone gum to make it waterproof. The output of this sensor is fed into the ADC pins of the MCU. When the ADC value goes beyond 75, which corresponds to 32 degrees, the MCU operates the water pump which draws the water from the aquarium and passes it through a cooling assembly, which is cold water in our case, and feeds it back to the aquarium until the temperature goes below 28 degrees, whose corresponding ADC value is 68. Now let's look at the demo. we cannot practically heat the aquarium to show the rise in temperature. Instead, we have kept a small quantity of lukewarm water in this glass, which imitates the situation where the temperature of the aquarium has gone beyond the desirable level. Initially, the sensor is in the aquarium whose temperature is below 32 degrees. Now, if I place the sensor in warm water, which simulates the condition that the temperature of the aquarium is above 32 degrees, the ADC value goes above 75 and MCU activates the water pump. This cooled water reduces the temperature of the aquarium water, and when the water is cooled to below 28 degrees, whose ADC value is 68, the pumping of the water is stopped. As the water is pumped out of the aquarium and back to it, the water inside the aquarium is set into motion. Moving water picks up more oxygen and also evaporates at a faster rate. That itself automatically cools the water inside the aquarium, thus reducing the power required to maintain the water in the cooling assembly at a lower temperature. In the end, we would like to thank Dr. C.P. Ravikumar for guiding us throughout the project and providing us substantial input through webinars. We also thank Mr. Vaibhav Oswal for responding to our queries in the forum. We wholeheartedly thank our mentor, Mr. N. Shivaprasad, for sparing us his time to ensure that we get the required resources on time. We would also like to sincerely thank Mr. M.J. Sampath Kumar for the quality time that he devoted to us. And of course, we would fail in our duty if we do not thank our friend Pawan Kishore for the editing work. We thank the entire TIIC team for their earnest support and resources in helping us to convert our project into a product.